Welcome to the channel, everybody. My name is Peyton. I'm the owner of Performance Driven Design LLC, and it is nice to be here. It's nice to finally be on YouTube. I've got some really cool stuff we're about to dive headfirst into today. I would say old cylinder head technology, older for me. We've got some leftover remnants of when Oldsmobile was in NASCAR that we're about to throw in this CNC and port. Why, you might ask? Why not? Stay tuned. Yeah. All right, so let's get into what we're going to be doing today. Please bear with me. I'm going to try not to sniffle a lot. My nose is running, and I unfortunately cannot catch it. Not in near as good a shape as I used to be, so running is out of the option. So, I have a Stage 3 CJ Batten Oldsmobile cylinder head, a pair. Actually, took us 12 years to put a pair of these together. These are both NOS untouched, blank slate. It's exactly what I wanted. We have a fun bracket racing project that we are putting together. 431 cubic inch small block DX Oldsmobile engine. Should make conservatively 820 or so with the parts that are going in it. But I have a untouched set of cylinder heads cast in the 1980s. So anytime you hear the word or name CJ Batten, I mean, the man was a pioneer. Did some really cool stuff, not just with Oldsmobile, but he is the creator of the first aftermarket, in general, cylinder head for Oldsmobile, and the first aluminum cylinder head for Oldsmobile. So here's what we've got. This is a Stage 3. This is the most sought after version of the Batten heads. This is an aluminum head. You see here we've got Batten. And when I say untouched, I mean it has nothing. No guides, no rocker studs, no push rod holes. Ports are as is. It has seats in it. You can see I've done a little bit of work to it. Started to do a little bit on this before I changed my mind and decided, you know, I want to get brave and throw it in the CNC. So why? Why, you might be asking, would I be chancing something that took me 11 years to get a pair of in the CNC? I want to. I'm a young man. I don't like being told no. Got a CNC. Who am I to avoid that temptation? So let's talk a little bit about a Batten head. These things came in several different variations. You would get a plus 50 or plus 100 valve arrangement, referring to how wide the valve spacing is. This is a plus 50 head. One thing about these that is different from the existing Oldsmobile heads is it has a slightly raised intake port. These heads were used in competition for NASCAR and NHRA competition back in the late 70s, early 80s. This is how they would get sent from the foundry to shops such as AJ Foyt, Buddy Baker, guys like that, and they would finish them out per their specifications on each shop. So what we're fixing to do, I'd like to get push rod holes in it. I would like to drill and tap for the rocker arms. Then we're going to turn on those extra 2 axes. I'm going to CNC port this thing. Stay tuned. I almost forgot. Let's talk about some of the differences between your Stage 1, Stage 2, Stage 3. This is not like you poor LS guys who have to see a Stage 1, 2, or 3 to understand how much power you're getting. Yes, I'm taking a jab. Your Stage 1 Batten heads were originally a cast iron head. Very good head, but oh my goodness, they're heavy. Just like any other cast iron head of that generation, I don't like messing with them. So the difference Your stage 2s and stage 3s are your most common Batten cylinder heads you will see. The most difference you will see right here on your rocker rail. The stage 2s have just a single rocker boss per valve pair. The stage 3s have a single bar rocker rail, which is that is one of the most aggravating things that happens on a Batten is rocker arm issues, just not a lot of rigidity right there. These heads were cast late 70s, early 80s technology, so you're not talking about the same spring pressures we're running today. Just a different time. So these have a it is a very modest intake port. A lot of guys will be able to get 340, 350 CFM out of these. Not outrageous. This is going to be a LS intake valve to 165. I'm going to put a 1650 exhaust in it. And the thing about these Batten heads is this exhaust is killer. I don't know why they felt, you know, let's raise the exhaust as high as we do, but only raise the intake that much. The exhaust in these things, you know, 280, 290 CFM. It is phenomenal. I mean, we're talking 75% of your intake flow, 80% even. So that's always what struck me as weird. I mean, the exhaust on these, which is what I based my billet head off of, is phenomenal. So it's going to be a really good head for what we're doing. Now let's hope we put holes where we intend to put them, to the CNC. All right, so we're over here at the CNC. This is a Haas UMC-750P. This is an interesting machine configuration because typically, you guys that know Haas machines, when you see a UMC, you're looking at a true 5-axis machine. This is set up as a 3-axis, your regular XYZ, +2 machine. We have a rotary A-axis with your typical B-axis trunnion configuration. This is a 2018 model, so this is your pre-revised UMC. When they came out with the 500, that was the new style. This is still the old configuration. Still has the big boy door on it. I've got, unfortunately, I know I made a jab at the LS guys. I've got an LS valve cover in here right now for DBR High Performance. Go check them out. Doing a little bit of engraving on it. So, I've got to take this trunnion plate out. We're going to put our Oldsmobile trunnion plate in. We're going to bolt the head to it. And we're going to start machining. Let's still hope we get it right. Cleanliness is next to godliness in machining, so you can see me bolt in the new fixture plate, wipe it with a towel followed by a hand wipe to make sure there's no burrs or chips on it. One thing I wish I'd have done different on this trunnion plate is do a bolt-in style for the cylinder head as opposed to a through bolt. Could have saved me a lot of time, but we learn by doing. All right, sweet. We are set up in the CNC machine. So now, here's where I get anal retentive. Your parts are only going to be as good as your fixture, and your fixture is only going to be as good as the amount of care you gave that day that you made it. So, being that this is a rare 1980s cylinder head, I mean, we're going to double, triple check our triple checks. So, what I'm fixing to do is I'm going to check this with my A-axis rotated to 0. So if I come over here, home the A-axis, I'm going to check, one, that I am flat from here to here on the deck surface. I'm going to check that I'm flat here to here. That will set my rotation. Should be flat the way it is, but we're checking our triple checks. So we're going to just roll everything over, check everything. Then I'm going to rotate it 90 just to check sweep here to here. I'm really not expecting this head to be very square. These were not done in a very high production environment. Truth be known, these were all done on Bridgeport style machines. So we don't know what we're going to get into. So it's very important in our case to know, that way I can adjust on the fly. And you know, both heads may be different. I may very well put both heads in here before I even cut the first one, just to make sure. am I going to make an exact pair out of them? Ideal in geometric perfection. This is a very non-geometrically perfect part. This is very organic. So we're going to ensure that these are exactly what we want them to be. And you know, it really doesn't matter what they are as long as they're the same. I can make this work if they're the same. So we're going to go through, check everything. We're probably going to clean both intake and exhaust face up. And while I've got you in here, let's talk about work coordinate. So this is obviously not a centroid or a rottler. Typically in your centroid and rottler machines, your work coordinate is going to be center of the head, center of rotation. So I don't have that here. I'm not working off those kinematics. So what I like to do for this machine is, you can see I've got a bored hole right here. Every time I scan a set of cylinder heads to do a port, I use a dowel or dowels as my head datum. So I've got head deck and I've got a dowel. In between two dowels, that sets this axis. So I'm using this bored hole, which is subsequently directly above that bore. That is my work coordinate system. So what I'll do is I will come in with the probe, I will probe this bore, I will probe the deck of the head, and poof, it's that easy. All you gotta do is hit the green button, right? Alright, so I've checked everything over. I like what I see. Both heads match-ish. We can work that out. So, what I've got in here right now is I'm fixing to bowl cut these seats. I've got a steel rougher right there. These have not been valve jobbed, and or rather what they have been valve jobbed is a lot smaller than what I've got going in there. So I want to clear out the throat size to what I've got sized for in the port. Let's see what it does. Looks pretty decent all the way around. Definitely missed our depth a little bit. That's okay. That's what wear offsets are for. All right, we got them done. Looking good all the way around. This should be very helpful when we get in there with the big lollipop. Definitely did not want to get in there with the lollipop on these. These are hardened steel alloy seats, so that would not be great for a 7-inch hangout tool to try to be doing some roughing on that. So we're good there. I think we're fixing to stick a lollipop in there, so let's see how this goes. While we're working through the rest of these intake ports, I wanted to take a moment and talk with you about what's actually happening in the machine. I've programmed this cylinder head in Mastercam using Port Expert. Phenomenal software to do porting with, makes it super easy. I'm using a 3-flute SFS carbide lollipop. I have individual programs per port, so I can get a good feel for what's happening per port, and if I need to make any tweaks, I can simply just go post a program as opposed to an entire program. I have this broken into 2 passes per port, a roughing pass and a finishing pass. The reason I have done that is because I'm taking quite a bit of material out of these ports, and I really want to have a very nice finish left in it. By doing so, I'm leaving 25 thousandths of stock left on the wall after my roughing pass. I know whatever I'm machining for the finishing pass is going to be a known amount of stock, which means constant cutter load, which means better surface finish. 500 surface foot per minute on the end mill, which is 3,819 RPM. 5 thou per tooth on the roughing for 57 inches a minute. 9 thou per tooth on the finishing for 91 inches a minute. that has yielded a very good combination for me thus far in the Haas. And back at it. Well, if you've made it this far, it is probably safe to assume we are now friends and like the same things. Appreciate you sticking around this long. Those of you with astute observational skills might realize this head is not done. And for that, I commend you for having common sense. No, this head is not done. We've got all the intake ports done, but I want to take my time, verify a couple more things. I'm really bad about second guessing myself. So before I do, I just ran out of time today, honestly, for the exhaust ports. I do want to double check all of my rocker arm geometry. Being that I'm putting an existing rocker arm system on this head, I want to make sure it's right. And I want to make sure that my rocker sweep and such is exactly what I want. This is going to be an offset rocker arm head. We're looking at a 275 offset intake. I believe it's a 180 offset exhaust. This is a T&D rocker system set up for Battens. I've got all of it in CAD. Just want to double check a few things, make sure I'm doing what I'm doing. So, I'm pretty pleased with how this turned out. Definitely a little bit of shadowing down in there. I did expect that, being that this head is what it is. It's all good. I am tickled to death with how it looks. Super swagalicious. So, I believe I'm going to turn this into a multi-part video series. Next video, we're going to do the exhaust. We're going to get all our rocker arm stuff situated, push rod holes, all of that good stuff. With that being said, if you like what we're doing, this is a very good taste of what this channel is going to be about. Not just going to be cylinder head related. I do a little bit of everything. If you can dream it, odds are I'm probably going to machine it. We do a lot of R&D. I'm here to give you my thought process. I'm not here to blow smoke up anybody's rear. Whatever it is, it is. I'm here to learn. I'm still learning, 25 years old. There is a whole world ahead of me which I've not got to experience. So odds are we're going to learn together. That's what I'm here for. We're going to get into a lot of stuff. I've got a lot of ambition. Definitely a little bit naive at times, a little overzealous. But you know, that's part of it. So, if you like what we're doing, like, share, subscribe. Tell everybody to go watch this weird little kid who's doing performance Oldsmobile stuff. Don't care. Until next time, I'm going to mull a couple things over. I'll catch you then. Thanks for watching.